Section 5.3 is all about kite and trapezoid properties. So take out your notes and put this into your table of contents, Section 5.3, Kite and Trapezoid Properties. So first, just a review. The definition of a kite in geometry class is a quadrilateral with two pairs of congruent consecutive sides. In other words, the sides are next to each other, the ones that are congruent. Now, some of the conjectures that you should have discovered today. The first one, the kite angles conjecture, says that the non-vertex angles are congruent. Next, we had the kite diagonals conjecture, which says that the diagonals of a kite are perpendicular. Next, we had that the kite diagonal bisector conjecture says that one diagonal is a bisector. So you'll notice that these two segments are congruent. Only one of the diagonals, not both of the diagonals. And then the last conjecture you should have in your notes is the kite angle bisector conjecture. And that one says that the vertex angles of a kite are bisected. So it tells me that those angles are that angle is bisected, so they make two congruent parts. And likewise, over on the other side, we have the other vertex angle bisected. Next figure is a trapezoid. And again, a review. Trapezoid, a quadrilateral is a trapezoid when it has exactly one pair of parallel sides. So again, I don't have this drawn in my notebook, but you should draw this trapezoid in your notebook. So we have the one pair of parallels, and the sides that are parallel are called the bases. So we have base 1 and base 2. It really doesn't matter which one you call base 1 or base 2. So for example, I could have switched them around and called one base 1, the other base 2. Doesn't really matter. The sides that are not bases are called legs. So we have leg 1 and leg 2. So that's our definition for trapezoid. Then we had a couple of conjectures along with them. First conjecture, the consecutive angles conjecture. What that says is consecutive angles between the bases are supplementary. So again, remember, your bases are the sides that are parallel. And so the angles would be, for example, angle R and angle T add up to 180 degrees. And likewise, angle A and angle P are supplementary. The next couple of conjectures deal with an isosceles trapezoid. So an isosceles trapezoid, for our definition, the isosceles trapezoids have congruent legs. So you'll notice in this shape, MA and HT are my congruent legs. MH and AT are my parallel bases. The first conjecture we had, the isosceles trapezoid conjecture, says that both pairs of base angles are congruent to each other. So in other words, angle M and angle H are congruent. Angle A and angle T are congruent. The other conjecture that you should have in your notes is the isosceles trapezoid diagonals conjecture. And that says that the diagonals of an isosceles trapezoid are congruent in length.